Mars, once a world potentially teeming with water and a thicker atmosphere, now stands as a barren, cold desert. What force could have stripped away its protective blanket? Some theories point to an unexpected culprit. Could Mars's air have been lost to a form of dark energy or perhaps other powerful cosmic forces? This question has puzzled scientists for decades. The answer holds profound implications for our understanding of planetary evolution. Billions of years ago, Mars possessed a substantial atmosphere capable of sustaining liquid water on its surface. Today, its atmosphere is incredibly thin, offering little protection from solar radiation or extreme temperatures. This dramatic transformation remains a central enigma. Evidence suggests a gradual, yet relentless erosion of its atmospheric gases into space. Understanding the precise mechanisms behind this loss is crucial for future human exploration. Scientists believe that powerful solar winds, unchecked by a strong magnetic field, played a significant role. These energetic particles from the sun bombarded Mars, stripping away its atmospheric components over eons. Other cosmic phenomena, such as asteroid impacts or even subtle gravitational interactions, might also have contributed. The interplay of these forces created a slow, irreversible process. It turned a potentially habitable world into the desolate landscape we observe today. New data, anticipated around 2025, promises to shed more light on these complex processes. Advanced missions are gathering unprecedented information about Mars's atmospheric escape. This research will refine our models and deepen our understanding of planetary habitability. The insights gained will present humanity with a critical choice. We must decide whether to invest in ambitious projects to rebuild a Martian atmosphere or accept the planet's current state. The loss accelerating. Dust storms doom Mars homes? This isn't a far-fetched science fiction scenario, but a critical question facing humanity's ambition to colonize the red planet. Mars is known for its dramatic and often planet-wide dust events. These aren't just minor inconveniences. They are powerful forces of nature. These colossal storms can engulf the entire planet, lasting for months on end. They dramatically alter the Martian environment, posing significant challenges to any long-term human presence. Understanding their true impact is paramount for future missions. One of the most immediate threats from these storms is the reduction of sunlight. Solar-powered equipment like our rovers relies entirely on clear skies. A planet-wide blackout becomes a very real possibility during these events. Consider the 2025 Rover Survival Challenge. How will future autonomous systems, or even human habitats, generate power when the sun is obscured for weeks? This energy crisis demands innovative solutions and robust backup systems. For human colonies, the stakes are even higher. Beyond power loss, dust storms present hazards like abrasive dust infiltration and extreme temperature fluctuations. Every piece of equipment, every habitat, must withstand this relentless assault. The question then becomes, fight or flee? Do we design colonies resilient enough to weather these storms indefinitely, or do we consider temporary evacuation or hibernation strategies? The engineering challenges are immense. Mars dust storms are a stark reminder of the planet's harsh realities. They are unpredictable, powerful, and potentially devastating. Our ability to establish a permanent foothold on Mars hinges on our capacity to overcome this fundamental environmental hurdle. The dust swallowing. Dark matter's 95% universe. Secret? For decades, scientists have grappled with a profound cosmic mystery. The vast majority of our universe remains entirely invisible to us. This unseen substance doesn't emit, absorb, or reflect light. Yet its gravitational pull shapes galaxies and clusters on the grandest scales. It's the universe's hidden architect. We infer dark matter's existence through its effects on visible matter. Without it, galaxies would simply fly apart. It acts as a cosmic scaffolding, holding everything together. This invisible material outweighs all the stars and planets we can see by a factor of 5. It dictates the very structure of the cosmos, yet we cannot directly observe it. Is dark matter the gravitational glue binding the universe, or is it a ghostly, exotic particle we've yet to identify? This fundamental question drives intense scientific inquiry. The invisible stuff rules, and understanding its nature is paramount. New experiments and observatories are constantly pushing the boundaries of our knowledge. Some researchers anticipate significant revelations around 2025, potentially shedding light on this elusive component. The quest to understand dark matter is a journey into the unknown. It challenges our fundamental understanding of physics and the cosmos. What secrets does this dominant, unseen force hold? Matter's hiding. #space success, #physics theory. Dark energy stretches the cosmic web, but how? This question lies at the heart of our understanding of the universe's grand architecture. It challenges our perceptions of cosmic evolution and the forces that shape everything we see. The universe isn't a uniform expanse, it's structured like a vast, intricate network. This cosmic web consists of massive galaxy clusters connected by long filaments of galaxies and dark matter. These structures are separated by immense, empty voids. For decades, scientists have observed that galaxies are not just moving, but accelerating away from each other. This expansion is driven by a mysterious force we call dark energy. It makes up about 68% of the universe's total energy density. Unlike gravity, which pulls matter together, dark energy exerts a repulsive force. It acts as a cosmic anti-gravity, pushing space itself apart. This constant outward pressure has profound implications for the cosmic web. The filaments of the cosmic web are essentially highways for galaxies. As dark energy continues to expand the universe, it's actively pulling these filaments apart. This creates an immense tension across the largest structures in existence. Scientists are keenly observing these dynamics, with new data expected around 2025 to shed more light on this cosmic tug-of-war. The question remains, will the web maintain its delicate balance? Or will the relentless pull of dark energy eventually tear it apart? Understanding this interplay is crucial for predicting the ultimate fate of the universe. Will galaxies eventually become isolated islands in an ever-expanding void? Or is there a limit to dark energy's influence? The implications are staggering, affecting everything from galaxy formation to the very fabric of space-time. The web's stretching. #space success, #dark energy. Could Mars's colossal dust storms be fueled by something as mysterious as dark energy? While the idea is captivating, the true power behind these planetary tempests lies in more conventional, yet equally formidable forces. These aren't just local squalls, they are atmospheric behemoths. Mars is known for its dramatic weather, but nothing compares to its global dust storms. These events can engulf the entire planet, transforming its familiar red landscape into a hazy ochre sphere. They are a stark reminder of the red planet's untamed nature. When a global dust storm ignites, it blocks out the sun, plunging the Martian surface into prolonged twilight. This solar occlusion poses an immense challenge for any mission relying on solar power. Rovers and habitats face critical energy shortages, threatening their very operation. Imagine a future human outpost, perhaps in a hypothetical 2025 mission, suddenly cut off from its primary power source. The dust infiltrates everything, coating solar panels and obscuring vital sensors. It's a test of endurance against an overwhelming natural force. For human explorers, these storms present a dire scenario. Reduced visibility makes surface operations impossible, and the fine dust can damage equipment and pose health risks. Survival hinges on robust engineering and meticulous planning. The question becomes, can humanity truly thrive on a world prone to such devastating atmospheric events? Or will these storms forever dictate the limits of our Martian ambitions? It's a constant battle against the planet's raw power. Scientists continue to study these powerful phenomena, seeking to understand their triggers and predict their onset. Each storm offers new data, revealing more about Mars's dynamic climate, yet much remains unknown about their full destructive potential. The next great Martian dust storm is not a matter of if, but when. And as we look towards future missions, the challenge looms large. The storm's building. Imagine the unimaginable. Does the universe loop? Could the Big Bang, the very beginning of everything, be destined to repeat itself? This profound question challenges our understanding of cosmic origins and ultimate fates. A compelling theory gaining traction around 2025 suggests a universe not expanding indefinitely, but one caught in an eternal cycle. This model proposes that after a period of expansion, the universe would eventually reverse course. This reversal would lead to a big crunch, where all matter and energy collapse back into an incredibly dense state. From this singularity, another Big Bang would ignite, initiating a new cycle of expansion and evolution. It paints a picture of cosmic rebirth, where the end of one universe is merely the beginning of the next. This concept offers an alternative to the idea of a universe expanding forever into cold, empty oblivion. This cyclical model raises fascinating questions about the nature of existence. Is each new universe a fresh start, a true rebirth with new laws and possibilities? Or is it an exact repetition, an echo of what came before, playing out the same cosmic drama? The implications are staggering, suggesting that time itself might be cyclical, without a true beginning or end. Our current universe could be just one chapter in an infinite cosmic story, a continuous cosmic dance of creation and destruction. This theory offers a captivating perspective on our place in the cosmos, hinting at a universe that is constantly renewing itself. It challenges us to reconsider the ultimate destiny of everything we know. The loop's closing. Primordial black holes are theoretical objects believed to have formed not from collapsing stars, but from density fluctuations in the very early universe. These ancient cosmic remnants could range dramatically in size, from microscopic to many times the mass of our Sun. Scientists ponder if these elusive entities might hold the key to one of the universe's greatest mysteries, dark matter. Imagine a future where unexplained cosmic explosions light up our telescopes, hinting at a hidden mass. These hypothetical events, perhaps observed around 2025, could be more than just distant supernovae or gamma-ray bursts. They might be the universe's most ancient secrets revealing themselves in spectacular fashion. Dark matter, an invisible substance, makes up about 27% of the universe's mass, yet we cannot directly observe it. Its gravitational pull shapes galaxies and large-scale cosmic structures. Primordial black holes are a leading candidate for what dark matter could be, offering a tangible explanation for this pervasive, unseen force. If these cosmic explosions were indeed linked to primordial black holes, it would revolutionize our understanding of dark matter and the universe's origins. Are these events genuine cosmic fireworks, or merely transient flashes misinterpreted by our current models? The scientific community grapples with distinguishing between groundbreaking discoveries and observational anomalies. The implications are profound. If primordial black holes are indeed dark matter, and if they are capable of such energetic phenomena, then our universe is far more dynamic and potentially volatile than we currently comprehend. The search for answers continues as the universe's deepest secrets remain just beyond our grasp. The bomb's detonating. Dark energy rips everything? This question might sound like science fiction, but it touches upon one of the most profound and unsettling theories about the universe's ultimate fate. For decades, scientists have grappled with the mysterious force known as dark energy. It's the unseen engine driving the accelerating expansion of our cosmos. This expansion isn't just happening, it's speeding up, pushing galaxies further apart at an ever-increasing rate. Dark energy constitutes roughly 68% of the universe's total energy density. Its nature remains one of the greatest puzzles in modern cosmology. Unlike gravity, which pulls matter together, dark energy exerts a repulsive force. This force is what causes the universe to expand faster and faster. Without it, the universe's expansion would slow down due to gravity, perhaps even leading to a big crunch. One extreme hypothesis stemming from dark energy's accelerating influence is the Big Rip. This theory suggests that if dark energy's density continues to increase, its repulsive force will eventually overcome all other forces. Initially, galaxies would be torn apart, then stars and planets. Ultimately, even atoms themselves would be ripped into their constituent particles. It's an end far more violent than a slow fade into cold darkness. The idea of the universe tearing apart, with some sensational headlines even mentioning a 2025 prediction, is certainly dramatic. However, current scientific models place any potential Big Rip billions of years in the future, if it happens at all. The rip starting is not an imminent event. The 2025 date often refers to a misinterpretation of specific cosmological calculations, not a consensus among physicists. The precise nature of dark energy is still unknown, making definitive predictions challenging. Whether the universe faces a big rip, a big freeze, or another unknown destiny, the study of dark energy continues to push the boundaries of our understanding. It reminds us of the vast mysteries that still lie beyond our current grasp. The universe's ultimate fate remains a subject of intense research and speculation. It's a journey into the unknown, driven by curiosity and the pursuit of fundamental truths. Mars once held vast oceans, but where did all that water go? For decades, scientists have puzzled over this profound mystery. Could an unseen cosmic force be the culprit behind Mars's lost seas? Evidence strongly suggests that early Mars was a wet world with liquid water flowing across its surface. Riverbeds, lake beds, and mineral deposits all point to a significantly different past. Today, Mars is a cold, arid desert, a stark contrast to its ancient, water-rich state. A groundbreaking theory proposes that dark energy might have played a role in this planetary transformation. This enigmatic force, known for accelerating the expansion of the universe, could have subtly influenced Mars' atmospheric escape. It suggests a cosmic connection to the planet's desiccation. This hypothesis posits that dark energy could have subtly altered the gravitational binding of Mars's atmosphere. Over billions of years, this minute influence might have contributed to the gradual stripping away of water vapor. It's a bold idea, linking planetary evolution to universal forces. Upcoming missions in 2025 and beyond aim to gather more definitive clues. These investigations will delve deeper into Mars's atmospheric history and geological composition. Scientists hope to find evidence that either supports or refutes this intriguing dark energy connection. Understanding Mars's past could offer vital insights into planetary habitability across the cosmos. If dark energy truly influenced its fate, it changes our perspective on how planets evolve. The question remains, can we revive Mars, or is it destined to remain a relic of a wetter past? The story of Mars's oceans is far from over. Oceans fading. Dark matter webs trap galaxies? This intriguing question lies at the heart of our understanding of the universe. Far from being empty, space is woven with an invisible, intricate network. This cosmic web dictates the large-scale structure of everything we observe. This vast network is primarily composed of dark matter, an enigmatic substance we cannot directly see. It forms filaments and nodes, connecting clusters of galaxies across billions of light-years. Ordinary matter, including stars and galaxies, then congregates along these dark matter highways. Galaxies are not randomly scattered throughout the cosmos. Instead, they are drawn together by the gravitational pull of these dark matter filaments. They cluster at the intersections, forming the massive structures we observe today. This arrangement is a direct consequence of the cosmic web's influence. Scientists are actively working to map this elusive structure. Upcoming missions and advanced telescopes, with data expected around 2025, aim to provide unprecedented views. These efforts will help us visualize the cosmic web's true extent and density. Understanding its architecture is crucial for comprehending galactic evolution. The cosmic web acts as a gravitational scaffold, guiding the formation and movement of galaxies. But is it also a snare? Does it merely provide a framework, or does it actively influence galactic properties and evolution in more profound ways? The answer could redefine our cosmic perspective. The gravitational forces within these filaments can accelerate galaxies, pulling them towards denser regions. This constant motion and interaction shape galactic destinies. The web's influence is a dynamic process, continuously molding the universe. The universe continues to evolve, and so does its underlying structure. As gravity works its slow, relentless magic, the cosmic web continues to draw matter together. The web's tightening. Mars once held vast oceans, rivers, and lakes. Evidence of ancient shorelines and riverbeds is etched across its surface, painting a picture of a warmer, wetter past. But where did all that water go? The question of Mars's lost water is one of the most compelling puzzles in planetary science. Mars bled its oceans. Gone? This dramatic transformation from a potentially habitable world to the arid planet we know today is a subject of intense study. Scientists believe the primary culprit is the solar wind. Unlike Earth, Mars lacks a strong global magnetic field to shield its atmosphere. Over billions of years, energetic particles from the sun relentlessly bombarded the Martian upper atmosphere. This constant assault stripped away atmospheric gases, including water vapor. Molecules were broken apart and their lighter components, like hydrogen, escaped into space. This process effectively blew Mars's atmosphere and with it, its precious water, into the void. Missions like NASA's MAVEN orbiter have provided crucial data measuring the rate at which Mars continues to lose its atmosphere today. These observations confirm that atmospheric escape is an ongoing process, albeit at a much slower rate now. Understanding this atmospheric bleed is vital for comprehending planetary evolution and the potential for life beyond Earth. The data helps us reconstruct Mars's ancient climate and predict its future. Upcoming missions, such as the proposed 2025 rover, aim to delve deeper into Mars's geological and atmospheric history. These advanced instruments will provide more precise measurements and insights into the mechanisms of atmospheric loss. They will search for further evidence of past water and signs of how the planet's environment changed over eons. The hope is to piece together the complete story of Mars's transformation. The bleed's continuing. #space, #space success, #dark energy. Imagine a force so powerful it could tear apart the very fabric of existence. Could dark energy truly be the universe's ultimate undoing, leading to a cosmic doomsday? This question haunts cosmologists and stargazers alike. For decades, scientists believed the universe's expansion was slowing down. Then, groundbreaking observations revealed a shocking truth. The expansion is actually accelerating. This mysterious force driving it is what we call dark energy. It's an enigmatic entity making up about 68% of the universe's total energy density. We cannot directly observe it, only infer its presence through its gravitational effects. Its nature remains one of the greatest puzzles in modern physics. Recent hypothetical data, perhaps from advanced telescopes in 2025, continues to confirm this relentless acceleration. Galaxies are not just moving apart, they are fleeing from each other at ever-increasing speeds. This cosmic separation is pushing the boundaries of our understanding. This means that in the distant future, our observable universe could shrink dramatically. Distant galaxies would eventually recede beyond our cosmic horizon, becoming forever invisible. What does this accelerating expansion mean for the universe's ultimate fate? One chilling theory is the Big Rip. If dark energy's density increases, it could eventually overcome all fundamental forces, tearing apart galaxies, stars, planets, and even atoms themselves. Another possibility is the Big Freeze or heat death, where the universe expands indefinitely, becoming cold, dark, and empty. All matter would eventually decay, leaving behind a desolate void. So, will the universe end with a sudden violent rip or a slow cold fade into oblivion? The data points to an accelerating expansion, but the final chapter is yet unwritten. What are your thoughts on dark energy's role in our cosmic destiny? The expansion's speeding. Imagine tiny black holes, remnants from the universe's earliest moments, suddenly exploding. Could 2025 be the year we witness such a spectacular, yet potentially terrifying event? The idea of primordial black holes bursting forth has captivated scientists for decades. These ancient microscopic singularities are theorized to have formed just fractions of a second after the Big Bang. Unlike their larger cousins, they aren't born from collapsing stars. Instead, they are relics of extreme density fluctuations in the very early universe. The renowned physicist Stephen Hawking proposed that black holes aren't entirely black. They slowly emit particles, a phenomenon known as Hawking radiation. Over vast stretches of cosmic time, this radiation causes black holes to lose mass and eventually evaporate. For primordial black holes, especially those with masses comparable to a mountain, this evaporation process could culminate in a final explosive burst. This burst would release an immense amount of energy in a very short period, potentially detectable across vast distances. Scientists are actively searching for signs of these elusive events. Observatories like LIGO, the Laser Interferometer Gravitational Wave Observatory, are designed to detect gravitational waves from cosmic phenomena. While LIGO primarily targets larger black hole mergers, future detectors might offer new avenues. The detection of such a burst would provide groundbreaking proof of Hawking radiation, a cornerstone of theoretical physics. It would offer unprecedented insights into the early universe and the fundamental nature of space-time. The prospect of a primordial black hole burst raises profound questions. Would it be a distant, harmless cosmic fireworks display? Or could it have more immediate implications if one were to occur closer to home? The energy released would be staggering. While the likelihood of a nearby burst is incredibly low, the scientific implications are immense. It would be a monumental discovery, reshaping our understanding of the cosmos. A burst's igniting.